Hello, I'm Dr. Rewa Wright, a researcher from the Future Arts Science Laboratory, we call it FAST Lab, at the School of Creative Industries and the University of Newcastle, New South Wales, Australia. I'm a media artist and designer working with virtual environments, self-organizing data, multi-user social VR, and the bioelectrical signals from plants. Today, I'll be talking about the emergent field of posthuman design and how that both challenges and fuels human creativity. Posthuman design investigates the aesthetics and materiality of new human-computer design assemblages. In this convergent media landscape, confluences of new technology and human creativity are arising at an increasing pace, incorporating a complex network of elements. There's not scope to cover everything within this short presentation. However, I will sketch an overview of the concept of posthumanism, delve into it as a philosophy, look at some essential techno-social forces of interest to current design culture, and of course, introduce a few case studies of areas that I think are particularly interesting. As a field, it's still finding its shape and form, but it's extremely useful, in my opinion, as a conceptual compass with which to navigate the space between humans, computational machines, and sustainable living on planet Earth. We need to work with all these three factors if we're to effectively design for a new future every day. It recognizes our connection as human designers, artists, and media practitioners to the world around us. We operate in an ecosystem that has two sides. On the one hand, the natural world, our life support system on planet Earth, the organic structure that provides oxygen, food, light, and an ecosystem within which we're embedded as Homo sapiens, human animals. As well, we've got our new computational ecology, where we operate alongside algorithms as co-creators and partners. Posthuman philosophy seeks to connect us to non-human actors in this wider ecology as partners and co-creators of a shared future assemblage. This presentation will take stock of a suite of interactive and intelligent technologies that challenge the traditional boundaries of the humanistic self. Examples of posthuman design include intelligent software agents, biosensors, Internet of Things, extensive computer vision such as AR, VR, robotics, artificial intelligence, machine learning, cryptography, and blockchain, to name a few notable methods and techniques. Such technologies directly impact society and culture, and whilst we may not always be aware of their presence, we experience the ambient effects of algorithms and computational hardware each day within social media networks. Our internet browsing history is governed via predictions, and in our public spaces, we find them increasingly smart and responsive in design. Objects are sensing us, just as we're sensing the natural world. Slowly, we are being reshaped into posthumans, where an embodied sense of self is reimagined through a persistent engagement with technologies that disrupt and extend physical boundaries. While this disruptive potential can sometimes be problematic, it also holds huge potential to be assistive. As this technology becomes increasingly self-organized and perhaps in the future even sentient, there is cause to rigorously investigate the impact on humans of these new forces, which are already bringing about immense societal change. The ongoing situation of the pandemic has accelerated this process even further, so that now we all collaborate, work, study, and experience large portions of our waking life online in extended virtual networks as virtual avatars. Together, in the talk that follows, we shall explore a range of design technologies that are reshaping our present and have a hand in determining our future. My aim here is to build an investigative framework through which to explore concepts and examples of the posthuman, using research methodologies drawn from philosophy, interaction design, and practice-based research in art and design. I'm going to be focusing on three areas: augmented and virtual reality, cryptography and design, and sensing networks that link humans, algorithms, and plants. So let's take a look at a range of these interfaces of expression, these new conjunctions of devices, networked assemblages, increasingly operated and governed by software that move us towards an understanding of what posthuman design actually is. First, I'm going to be talking about the shifting perceptions that occur through augmented, virtual, and extended reality. The philosopher and physicist Karen Barad asks us to consider her concept of agential realism, which gives thought to the specific forms of situated knowing that contribute to our perspective, position, and vision. We're fundamentally entangled with the world in which we live, an embedded and responsive node in a network of human and non-human actors, operating from our own agentially real perspective of situated knowing. The implications for knowledge in this line of thought are ontologically and epistemologically profound. Knowledge does not lie in an abstract state waiting to be discovered. Rather, as designers, scientists, researchers, and scholars, we are but one recursive feedback loop in a responsive knowledge economy where we share our place with non-human actors in a techno-environmental web composed of many threads. We're an entangled part of the knowledge systems with which we interact, and those actions shape creativity itself. This is a fundamental shift from humanist thinking and marks the usefulness of posthumanism to the intersectional field of design, media, and technology. What situated knowing means for the human subject engaged in augmented, virtual, and extended reality is that the apparati that we wear, the phenomenon, the visual and perceptual shifts that we experience when we're in immersion, when we're wearing a headset, when we're traveling as an avatar in an extended reality web space, these are all shaping our experience of life, and we actually take traces of them with us once we take the headset off, once we move back into the real world. We carry traces with us in an embodied state. Our sense of situated knowing is being shifted by technology. This is not a negative thing, this is a positive thing, where we have the opportunity to form partnerships with new modes of technology and extend our human selves. This idea of embodiment is crucial here, where we carry traces of a previous experience with us. So whenever we experience technology, even if it's as simple as something on a smartphone, an augmented reality experience that we might have while we're walking around, perhaps a game that we're playing in public space on our phones, these are all experiences that shift our perception. And when we put our phone down, when we move to a new space, we still have that memory with us. It's like a layer that alters our sense of embodiment. You know, we naturally, as humans, have a sense of plasticity where we're able to reshape our own synapse depending on the experiences that we have. Operating from this position of situated knowing becomes a very important part of life with technology. When engaged with AR, VR, and extended reality, our perceptions shift so that this new reality is actually co-created with the algorithms and hardware devices that we wear, that we engage with. They're not simply our tools. This is a misconception because they are responsive in themselves. They are increasingly sensing us. In these new senses of perception to which we're embedded and entangled, it's not only a visual state, but also tactile, gestural, and embodied. This is a slide from some of my own work with plants. I've been working with plant sensing for about 5 years now, especially looking at the bioelectrical signals coming out of plants and how they can be used in performative installations. So this aspect of my interaction design, I also blend with digital augments, tracked to my hand using the Leap Motion controller. As I'm touching the plant, augments emerge, and I'm actually able to control those while modulating the plant's leaves so that I'm actually playing the plant sonics like an instrument. In terms of our embodiment, we need to think of how extensions of reality might shift our sense of self. Embodiment involves a person carrying traces of a previous experience, which unfold again through the process and passage of life. As well, our embodied sense of self is malleable, and it's reimagined through a pervasive engagement with immersive technology. These engagements challenge and extend our physical boundaries. They shift us. Another area that I think is really fascinating right now is cryptography. So posthuman concepts and their material enactment are extremely pertinent to the blockchain space, where the future of currency is currently being redesigned. Each operation on the blockchain is enacted by algorithms as partners in all transactions. Most people know what blockchain is, but I'm briefly going to summarize it for those who aren't familiar before moving on to its implications for design and the specific example of non-fungible tokens or NFTs. A blockchain is a decentralized database shared across a computational network, maintained by a network of validator nodes and governed by code. This takes the form of a real-time ledger, storing transactions sent and received. The network of nodes acting as validators use various mechanisms such as proof of work in the case of first and second generation ledgers like Bitcoin or Ethereum, or proof of stake in the case of newer cryptos like Tezos or Cosmos. But why is blockchain important from a design perspective? On the surface, it just seems like some kind of accounting innovation, a simple ledger, a way of keeping track of the small pieces of life more easily, a functional system. However, it's the capacity for blockchains to revolutionize a variety of real-world applications that makes their design so special. Data stored on the blockchain is immutable and transparent. The ledger cannot be altered or tampered with. Anyone using a block explorer can view the transactions. However, owners are anonymized behind a transaction ID. The important feature of trustless validation means a human agent is not needed to verify that a transaction has taken place. Algorithms take on a huge significance in this space as they fundamentally structure all blockchain ecosystems. By removing human bias, code becomes law. The implication is that blockchains can be trusted, whereas humans cannot, leading to numerous use cases, especially around areas where we need to increase greater equity and greater fairness. So the main difference between cryptocurrency and NFTs is that one is a fungible token, such as Bitcoin or Ethereum. Those tokens can be exchanged with others of the same value. They're not unique. A non-fungible token cannot be exchanged of something of the same value because it is unique. It has no peer. It's therefore a rare object. We also have Nyan Cat, a 12-frame GIF made by the original artist who created the Nyan Cat meme. And if it seems like a lot of money for a GIF, think of the amount of time that Nyan Cat's been reproduced on the internet with no royalties going to the artist, who's previously received no income from this immensely popular design, which has been copied millions of times by others. NFTs allow for the fair monetization of digital objects and are a boon for starving designers who've been economically hit by the pandemic. Therefore, they've created a new art market where designers and artists can directly connect with an audience who have a ready and easy means to pay them on a blockchain, and they're able to receive their goods the same way. So on a less aesthetically frivolous note, NFTs are also developing an array of compelling use cases. In real estate, they're a way to monetize rental properties and apportion timeshares. In medicine, they're a radical new method to prove ownership of genome sequences. This research has recently come out actually from Professor George Church, who's a co-founder of Nebula Genomics and a professor of genetics at the Harvard Medical School. So Professor Church is minting a non-fungible token of his own genomic data, which is a world first. In the global south, we find NFTs are also a viable method for fairly distributing charitable donations. Contracts exist for many types of collectible. You've probably seen NBA Top Shots, it's really popular right now. Overall, they're a very direct way for artists and designers to sell their work without using a physical gallery or an agent, and this is an extremely important feature in the 21st century. The next area I'd like to talk about is to do with living plants. Bit of a change from the blockchain, but there's a lot of interesting research happening with living plants. They're another non-human actor in this shared ecosystem. So on the one hand, we have algorithms. We can think about cryptocurrency and blockchain as being governed by algorithms. But another major non-human actor is actually the organic world. So we have non-human animals, but as well, we have the plants who actually create our life support system in this biosphere, planet Earth. So they're an extremely important part of sustainable living. We need to consider them with all future human development. And unfortunately, they're in quite a poor state right now, thanks to climate change. So it's crucial for designers now to think about our relationship with plants, how we can maximize our relationship with them, and how we can try to enhance life on planet Earth for all species. There's some really fascinating research actually around harnessing the bioelectrical signals from living plants. And this has come up as an important area of research in recent decades. So notable advances have been made in various design-related fields. For example, in nanotechnology, engineers at MIT have transformed spinach into sensors capable of detecting explosive materials. These plants are then able to wirelessly relay this information back to the scientists. So in the field of nanobionics, engineers are able to embed sensors and electrical systems into plants, which can then connect to the Internet of Things, co-creating data relays that perform important functions like warning humans about climate change. Professor Michael Strano, who led the research just published in March 2021 on this subject, has said this is a novel demonstration of how we've overcome the plant-human communication barrier. So I think this type of research proves that we need to think a different way about communication. In human terms, we tend to think of it as verbal, the way I'm speaking with you now. However, in terms of interspecies communication, especially with plants, we need to think about electrical signals, enzymes. We need to think about their plant processes and how we can break that communication barrier. Some more fascinating research actually also from Professor Strano, this time in partnership with MIT architecture professor Sheila Kennedy. They've together created a sustainable urban building architecture that incorporates light-emitting plants using the enzyme luciferase, which is the same enzyme that gives fireflies their glow. So imagine in the future you could be sitting in your lounge reading a book by plant light. So the concept of connecting plants with media technologies is not new. It was sort of arisen in the 1970s actually. The famous Korean artist Namjoon Paik, TV Garden is probably one of the first examples, influential design pieces involving plants in a media environment. Also, the American composer John Cage from 1975 began to sonify the electrical signals from cacti plants and using these as musical instruments played by a performer. Plants have now become live performers in their own right, co-creating alongside human musicians. Also in the 1970s, Richard Lowenberg and John Lifton used the gold needle technique to measure the bioelectrical signals from plants, transferring those signals to electroencephalography or EEG devices worn by human performers. Their installations featured in the film The Secret Life of Plants. This thread's kept going into the 1990s. There are some very key projects that communicate the idea that plants have their own particular sense of agency, a sense of situated knowing, as we discussed before. They're not simply passive objects or primarily aesthetic material. So in the seminal installation Interactive Plant Growing by Krista Summerer and Laurent Mignonneau from 1992, participants were able to touch real plants and precipitate the on-screen growth of up to 25 species of digital plants. The screen growth was only activated if people found the right combination of tactile micro gestures. So they needed to touch the plants in a very particular way so that the digital plant would grow on screen, or what would grow on the screen would be an invasive plant or a weed. So there was a sense that people had to tune in to the actual tactile feeling of the plant's leaves. So tactility here emerges as a strategy to offer a kind of rich interrogation into plant-human relations that goes beyond visual aesthetics. So I've discussed a range of convergent data mechanisms, informatic flows, and conceptual reimaginings that gesture towards the post-human. So far, I've discussed post-human design as having an affinity with various types of networked assemblage, where an assemblage is a vibrant and self-organizing structure capable of encompassing organic and inorganic life forms as responsive nodes in a network assemblage. But zooming out to a more philosophical frame, is there a fundamental formulation we might apply to describe all of these things? We're now increasingly assembled by the software we create. However, that software is not simply our tool because it's also responsive. There are also intelligent software agents, and one day those agents could become sentient. They may approach a life of their own. So I think we need to look at a core organizational structure. And the structure I use, the term I use, is called the software assemblage. This is where we as humans are assembled by software, but we're also responsive to it. So we're entangled in an ecosystem with software as a non-human actor. Coming into that ecosystem as well as plants, as we saw in the example from the MIT Media Lab, Professor Strano, plants are also entangled with data now in these responsive networks that connect up to the Internet of Things, for example. So does this mean we've lost control as humans in this new hybrid reality? No, I believe it does not. However, what it does mean is that we have algorithms in all their forms now operating as our responsive partners, our co-creators in an everyday future where data, bodies, organisms of all kinds, human and non-human, conflate and converge. Taking the stance that human life is now a collaborative ecology where we co-design our reality with our non-human partners, it's evident that life itself is not a category reserved only for organic organisms. Rather, human life is enhanced, challenged, disrupted, and extended by the entangled network of partnerships we make with non-human forces. Together, we form software assemblages with algorithms and code on the one hand, and plants and non-human animals on the other.